Now let us discuss chapter 9, areas of parallelogram and triangles. So we have already learned how to find the area of some figures in lower classes, no? Like triangle, rectangle. Okay, so in 8th standard someone we have learned how the area of trapezium and parallelogram, like that. So what is the relation between parallelograms and area of parallelograms and triangles on that same base, that we are going to learn. Now if two figures are congruent, then congruent means they will have the same shape and size, then they will have the same area. But congruent figures will have the same area, but see here, two figures are there. Their area, if you are taking 9 into 4, that is 36. Here it is a square, that area is equal to again 36, but they are not congruent figures. So congruent figures will have same area, but if two figures have same area, that doesn't means they are congruent figures. So in this case, one is rectangle, other one is square. Both of them are having the same area, that is 36 centimeter square. So now let us this type of figures also we have discussed how to find out the area of such figures. So we have to divide it into non-figures, then find the area separately, then add the areas of that one. Now let us discuss in this chapter figures on the same base and between the same parallel. Now look at here. See, ABCD is a trapezium and EFDC is a parallelogram. They have the same base, DC. Okay, figure page number 154 1. Then look at this one. Two parallelograms are there, PQRS and MNRS. They have the same base, RS. Okay, two parallelograms. Here two triangles are there. One is ABC, another one is BDC. They have the same base, BC. And here one parallelogram and another one is a triangle. One parallelogram ABCD and triangle PDC, both of them are on the same base, DC. Now we are going to discuss the figures on the same base and between the same parallel. That is, look at the figure here. One trapezium is there, ABCD. Another parallelogram is there, EFDC. Both of them are on the same base, CD. And here, and they are in between the same parallel, DC and AF. Now here, look at here, second one. One is a parallelogram PSRQ or PQRS, you can take. Another one is MNRS. Both of them are on the same base, RS, and between the parallels RS and PN. Now another triangle, two triangles are there. So ABC and DBC, both of them are on the same base, BC, and between the parallels AD and BC. Now here one is a parallelogram ABCD, another is a triangle PDC. Both of them are on the same base DC and in between the same parallel DC and AP. Okay, so now look at this 9.1. Which of the following figures lie on the same base and between the same parallels? In such a case, write the common base and the two parallels. Now look at here, first figure. First figure, one is ABCD, is a trapezium, and PDC is a triangle. Both of them have the same base DC and between DC and AB. Okay, so what is the common base here? DC, and which is the parallel, that is AB and DC. Now look at here, one is a trapezium MNSR and another one is a parallelogram PQRS. Both of them have the same base SR but not on the same parallel. Okay, now here one parallelogram PQRS and a triangle TQR. This one is a triangle, same bases RQ and between the parallel RQ and PS. Okay, you have to look at here, look at this one. Now here they are not on the same base. Now that triangle is smaller than smaller part only. Okay, sharing a part of the base only, so it will not come. Now here two trapeziums are there. One is DQ ABQD. Another one is APCD. Both of them are the same base AD and between the same parallel AD and BQ. Now this one is not possible. So in this figures only for 1, 3rd and 5th one is in between the same parallel and on the same base it will come. Now let us discuss theorem 9.1. Parallelograms on the same base and between the same parallel are equal in area. Now look at this one. Two parallelograms are given in this figure. Figure 9.12. Which are they? One is a parallelogram ABCD. Another one is EFCD. So they have the same base DC and between the same parallel DC and AF. The theorem says that they have the same area. Now when you look at the figure, ABCD means this much part and EFCD means this much part. That means if you are proving this part is common to both, EBCD is common to ABCD and EFCD. So if you are proving these two triangles are congruent, then we can say they have the same area. Now for that one, they have taken the triangle ADE and triangle BCF. Now look at here, they have given DAE, DAE and CBF. They are corresponding angle. Why corresponding angle? These two, AD and BC are parallel lines. So parallel lines and upper side. So corresponding angles are equal. Like that, AED will be equal to BFC. Same reason, corresponding angle. Now, if two angles are equal, third angle will be also equal. That is the angle sum property, because three angles together it will be 180. If two are equal, then that means third one also will be equal to the third one of this angle. So, three angles are equal. Now, then AD is equal to BC. You can take AD and BC are the opposite sides of the parallelogram ABCD. So opposite sides of parallelogram are equal. So AD equal to BC you can take. So by ASA theorem, these two triangles are congruent. So what you have to do? You got that these two triangles are congruent. So what will be the area of ABCD? Area of ABCD will be area of ADE plus this part, that is EBCD. Then but ADE is same as BCF. Then plus EDCB means it is the area of parallelogram EFCD. Okay, that means parallelogram on the same base and between the same parallels are equal in area. You don't have to learn the proof, but theorem you have to learn. What is the theorem? Parallelograms on the same base and between the same parallel are equal in area. Now, theorem 9.2, two triangles on the same base and between the same parallels are equal area. See, this two triangles are given. Two triangles on the same base, that is first one we have taken ABCD a parallelogram. Then diagonal one we have made. So AN is perpendicular. So ADC and CBE, when you are taking angle, area of ADC will be equal to CBE, because it is a triangle. So half of base into altitude. That altitude means perpendicular one, that will be same for this and this triangle. That means area of these two figures will be same. So if two triangles are there on the same base and between the same parallel, they will be having the equal area. Now 9.3, two triangles having the same base and equal area lie between the same parallel. That is converse of this theorem. That is, two triangles, if they have the same base and equal area, they will be in between the same parallel. Proof is not there. So this is only this from the ninth chapter. Only you have to learn the theorem so that we can next year make use of that one. Theorems you should know. So what we have learned now, that is first one is parallelograms having the same base and between the same parallels will have the same area, and triangles having the same base and between the same parallel will be also having the same area. That is the two properties we have learned in this chapter. So next chapter, 10th lesson, we have to learn in detail. Just go through this summary. If you have doubt, you can ask me. See this one, 12th point, they have given a median of a triangle. Divide it into two triangles of equal area. Median means what? From one vertex to the midpoint of the other two sides. That length, that one is called the median. Okay. So median will divide the two triangles in equal area. That is the extra thing they have given in this one. And area of triangle, that we have already learned in 8th standard. Area of triangle is half the product of base and corresponding altitude. Then area of parallelogram is base and altitude, product of base and altitude. Okay, so just go through this one. You have to learn this one so that we can questions of true or false will come from the statements.